Hello everyone, today we are going to be covering equivalent ratios. First, let's talk about what an equivalent ratio is. It is a pair of ratios that have the same relationship between the numbers. Now that might not make sense right now, but it's going to by the end of this video. In order to find an equivalent ratio, we have to start with the ratio. So we're going to start with the ratio of 1 to 2. It's very simple to look at. And I've written it down here, the 3 different ways that we've talked about so far in this unit. So first of all, what I want to talk about is the numbers having the same relationship between them. Now we only have one ratio here, it's 1 to 2. We have not found an equivalent ratio yet, but I want to talk about how the relationship is between the 1 and the 2 in this case. If I were to describe the relationship between the 1 and the 2 here, I would say that the 2 is 2 times greater or double the other number in our ratio. So we need to maintain that throughout this problem. There are many ways to find equivalent ratios. The first one we're going to talk about is just multiplying each side of the ratio by the same number and seeing what the result is. So we're going to use 1 to 2, and we're just going to multiply the next whole number. We're going to multiply by a scale factor of 2 to both sides of our ratio. All right, this is the important part. You have to do the same to one side as you do to the other. It's kind of like finding equivalent fractions. You have to multiply the numerator and the denominator by the same thing. So let's go ahead and do this. 1 times 2 would be 2, and 2 times 2 would be 4. So what I can conclude from this is that 2 to 4 is an equivalent ratio to 1 to 2 because they maintain the same relationship between the two numbers. What do I mean by that? If you were to rewind this video, you would remember that we said that 2 was twice as big as 1 in that first ratio. And if we look at the second ratio that we created, the equivalent ratio, 4 is twice as big as 2. So we maintain that same relationship. It's twice as big, or it doubled. Let's go ahead and work through another one with a different ratio to start with. Our beginning ratio here is 2 dogs to 8 cats. The relationship between the two numbers in our ratio here is that there are 4 times as many cats as there are dogs. So let's go ahead and scale this ratio up. Let's go ahead and just multiply by, let's use 3 this time. Multiply by 3. If we multiply both of these numbers by 3, we would find that we would have 6 dogs to 24 cats. Does this maintain that 4 times as many cats as dogs ratio? It does. 6 times 4 would equal 24, just like 2 times 4 would equal 8. So this 6 dogs to 24 cats is an equivalent ratio. Well, in the first part of the problem, you can see that we scaled this ratio up. We could also scale this ratio down and find a smaller equivalent ratio. So let's go ahead and do that. In order to scale down, we're just going to divide by the same whole number on both sides of our ratio. So like we multiplied by 3 up here, we are going to actually divide by a whole number here. Let's go ahead and use 6. We're going to divide by 6 on both sides of this ratio. So 6 divided by 6 would be 1, and 24 divided by 6 would be 4. We should have added our labels, so I'm going to rewrite this. So if we just focus on the bottom down here on what we just completed, 1 dog to 4 cats, let's go ahead and make sure that we maintain that same relationship within our ratio. If we were to take 1 dog, and if we had 4 times as many cats, well, we would have 4 cats. So we maintain that same ratio. What does that mean? Well, it means that this is an equivalent ratio to both 6 dogs and 24 cats, and it's an equivalent ratio to 2 dogs and 2 dogs to 8 cats. So just to clean things up a little bit and to reinforce this, all of these ratios are equivalent to one another because they maintain that same ratio of there being 4 times as many cats as there are dogs.